Hello guys, my name is John Michael Reyes and this is the chapter 4, the transport layer, and for that and I'm discussing the summary of it because we are task 2. Then transport layer prepares application data for transport over the network and processes network data for use by applications. The responsibilities of transport layer are some tracking the individual communication between application and the source and destination host, segmenting data encapsulation, and adding headers to indicate which communication it is associated, and segmenting data encapsulation, adding headers to indicate which communication it is associated, assembling the segments into streams of the application data included by information in header, then identifying the different application by assigning identifiers, part numbers to indicate to which application that piece of data is associated, then application generate data that is sent from one to another without regard to, then the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion of link, the size of the network. Then lower layers are not aware there are multiple applications sending data on the network, responsible to deliver data to appropriate devices. Then there are multiple transport layers protocol between, because different applications have different requirements. Then the transport layers segment the data and manages the separation of the data for different applications. Primary function is specified by all transport layers. Protocol includes segmentation and reassemblability, limitation to amount the data of included in a single PDU, then conversation multiplexing. Some protocols provide connection-oriented conversation, reliable delivery, ordered data reconstruction, flow control, along with the header information, port number. Then establishing a session can create session between application, prepare the application to communicate with each other before data is transmitted. Data can be closely managed, reliable delivery, ensure that all pieces reach their destination by having the source device transmit any data that is lost. Then same order delivery by numbering and sequencing the segment ensures that their segment are reassembled in proper order. Then flow control, when the transport layer is aware that resources are overtaxed, some protocols can request that the sending application reduce the rate of data flow. Then transport layer manage the application data for conversations between hosts. Then transport layer 3 basic operations. Reliability are tracking data transmitted, acknowledging received data, retransmitting unacknowledged data. Then source transport layer operation keep tracks of all the data pieces of each conversation and the transmission of any data that was not acknowledged by the destination host. Destination transport layer operation tracks the data is received and acknowledged the recipient of data. Then transport layer protocols and that specify methods for either reliable, guaranteed delivery or best effort delivery. Reliability protocol databases, web pages, and emails. Then non-reliable protocol are video streamings and other stuff. Then two most common protocol in transport layer TCP or IP model is TCP and UDP. TCP is transmission control protocol and UDP is user datagram protocol. UDP is somewhat simple and connectionless, low overhead data delivery. Pieces of communication are called datagrams that are sent as best effort application that use RDNS, video streaming, and VoIP. 8 byte of overhead, then TCP connection oriented incur additional overhead in header, then encapsulating the application layer data, and application that use web browsers, emails, and file transfers, then port number, TCP and UDP basis services keep track of various applications that are communicating to differentiate segment and datagram for each application. Both TCP and UDP have header fields that can uniquely identify these applications. Then source port number of this connection associated with the originating application on the local host. Then the destination port is number for this communication associated with the destination application on the remote host. Then socket combination of transport layer port number and network layer IP addresses. Then the socket pairs are consisting of source and destination IP addresses and port numbers. Then POP3 or POP1, POP110, and HTTP. The port is 80. Then IM is port 531. Then the well-known. Then the registered ports are 1024 to 49151. Then dynamic private peripheral ports are 49152, then 65535, and UDP ports are registered and other stuff. The netstat shows that active TCP connection that are opened and running on network host, list protocol in use, local address and port numbers, foreign address and port numbers, state of connection used to examine and to open connections on a host when performance appeared to be compromised. Then PDU TCP headers sequence number allows the transport layer function on the destination host to reassemble segments in the order in which they were transmitted. UDP has no sequence number fast transfer of data through. Then UDP header source and destination ports. Then TCP header source and destination port sequencing for same order delivery, acknowledgement for receive segment flow control and other stuff. Then the TCP reliability. Then after session has been established, acknowledgement sent from the user successfully. Then TCP additional overhead on network traffic generated by acknowledgement and retransmission. Then reliability is achieved by having fields in TCP segments. Then three-way handshake and other stuff. Then what do we call the others? Then session terminal. Then sequence numbers, relative numbers of bytes that have been retransmitted in session plus 1. Then exceptional acknowledgement numbers in segments in sent back to source. Then the window size, the amount of data that a source can transmit before an acknowledgement must be received. Then selective acknowledgement makes possible for this destination to acknowledge bytes in this continuous segments, and host only needs to retransmit the missing data. Flow control assists the reliability of TCP transmission by adjusting the effective rate of data flow between two services in a session. Then the other stuff is UDP. UDP is a simple protocol connectionless to provide basic transport layer function. Then the datagram is a UDP PDU. UDP does not keep track of sequence number, no way to reorder the datagram into their transmission order, then UDP-based server application are assigned well-known registered port numbers, then randomizers port numbers help with security if there is predictable pattern for destination. Then once a client has chosen source ports and other stuff, the same of ports is used in the header of all datagrams used to transactions. Port numbers are served for return datagram header, and that's all for chapter 4. Thank you.